Good afternoon, everyone, and welcome to today's webinar, Using SimMan for Advanced Ventilator Management Training. Before we get started, I'd like to go over a few housekeeping items so you know how to participate in today's event. Though your microphones will remain muted throughout today's presentation, you will have the opportunity to submit text questions to today's presenters by typing your questions into the Q&A pane of the control panel on the bottom of your screen. You may send in your questions at any time during the presentation. We will collect these and address as many of them as possible during the Q&A session at the end of today's presentation. Those we don't get to will be answered and made available to all of you early next week, along with the recording of today's presentation. We will also offer the opportunity to sign up for more detailed follow-up demonstrations with today's presenters. I'd like to welcome customers of IngMar, Laerdal customers, and those who are new to both of us. I'd also like to offer a special hello to those joining us from the SimOne conference in Canada. I would now like to introduce Brian Lynn, Product Manager at IngMar Medical, and Joe Hughes, Patient Care Account Executive at Laerdal Medical. Brian?
Thanks. As Cassie mentioned, my name is Brian Lynn, and I am the Product Manager at IngMar Medical. First, I'd like to thank everyone for joining us today. We have hundreds of people from all over the world listening in, so we're thrilled to have this opportunity to talk to you about this new collaboration. Because some of you may not be very familiar with our company, I'd like to give you a brief overview of IngMar Medical. IngMar Medical was founded in 1993, and we are located in Pittsburgh, Pennsylvania, in the United States. We have established ourselves as the global leader in respiratory simulation by providing lung simulation solutions such as the ASL 5000 breathing simulator that you will be learning about today. Our mission as a company has always been to establish better outcomes for patients supported by respiratory devices, such as a ventilator. We've done this by helping researchers and engineers improve device development and quality assurance, and by helping educators provide realistic, hands-on training. One day, we hope to play an integral role in helping simulation become the worldwide standard for mechanical ventilation.
Good afternoon. This is Joe Hughes with Laerdal Medical, and as Cassie said, I'm one of our patient care account executive. Since 1949, Laerdal's headquarters has been located in Stavanger, Norway. Today, Laerdal is an international company with more than 1,400 employees worldwide. This year, we are actually celebrating our 50th anniversary in the United States, with our main Americas office located in Wappingers Falls, New York. Our mission has always been helping save lives, and our vision is that no one should die or be disabled unnecessarily during birth or from sudden illness, trauma, or medical errors. Our goal is to help save 500,000 more lives every year by implementing what has been shown to work within resuscitation research, improving patient safety, and our global health initiatives. We strongly believe we can achieve our goal.
Thanks, Joe. Now, we would like to introduce you to a new solution which allows customers to integrate our most realistic breathing simulator, the ASL 5000, with the Laerdal SimMan platform. I'd like to start by giving you some context on the ASL 5000 breathing simulator and how it works. Here, you can see an image of the ASL 5000. Within this box, there is a piston inside of a cylinder. With our software program, we precisely control the movement of the piston to create breathing patterns based on the equation of motion. Today, we will be showing you a solution which allows you to integrate these breaths with the SimMan mannequin. But it is worth noting that you can simply connect a standard patient circuit from the ventilator to the 22mm port on the front, and the ventilator will sense the breaths produced by the ASL 5000 as it would a real patient. The power and versatility of the ASL 5000 comes from its sophisticated control over three main types of parameters: resistance, compliance, and spontaneous effort. With the ASL 5000, you can select any resistance value from 8 to 150 centimeters of water per liter per second. This range of resistance values represents essentially any condition from a fully healthy airway or low resistance values to one that is severely obstructed or high resistance values. You can also select any compliance value from 0.5 to 250 milliliters per centimeter of water. A low compliance value represents a stiff lung, and this is indicative of disease states such as fibrosis or ARDS. A high compliance value represents a lung that is too elastic, like emphysema or COPD. This unparalleled versatility for setting resistance and compliance is used to carefully construct disease state models, such as ARDS, COPD, asthma, a pneumothorax, and many more. To create more sophisticated lung models, we have provided two advanced features related to resistance and compliance. First, customers have the ability to create two-compartment lung models in order to simulate conditions like a pneumothorax. The second feature allows you to set inspiratory resistance and expiratory resistance independently, which is critical for simulating certain respiratory conditions such as severe asthma. But in my opinion, the biggest advantage of adopting the ASL 5000 breaths is the ability to simulate a patient who is breathing spontaneously while being ventilated. Using the movement of the piston inside of the ASL 5000, your SimMan mannequin will produce negative pressures sensed by the ventilator as a patient effort. This means you can provide training on any mode of ventilation, and you can craft real-life scenarios on advanced ventilator management topics, such as patient ventilator synchrony, weaning trials, and waveform analysis. When connected to the ASL 5000 breathing simulator, the SimMan has a total volume capacity of approximately 2.5 liters. This means any clinically relevant PEEP value can be applied, even values greater than 20 centimeters of water. For several years, our customers have been requesting a solution that would allow them to utilize the breaths produced by the ASL 5000 in conjunction with the comprehensive functionality of the Laerdal SimMan.
Thank you, Brian. At Laerdal, we frequently work with customers needing the ability to manage SimMan as a ventilated patient, responding to assisted ventilation, PEEP, and other advanced respiratory management techniques, with the option to also simulate various respiratory disease states. We are now excited to introduce two new products developed in collaboration, the ASL 5000 lung adapter and the ASL 5000 lung solution. The ASL 5000 lung adapter refers to the hardware and software necessary to integrate the ASL 5000 with members of the current Laerdal SimMan family. The ASL 5000 lung solution is the full solution, including both the lung adapter and the ASL 5000 breathing simulator itself. The lung solution is currently compatible with the SimMan 3G, SimMan Essential, SimMan Essential Bleeding, and SimMan 3G Trauma. The lung adapter includes a hardware component which allows us to physically bypass the SimMan lung bags with the breaths created by the ASL 5000. Laerdal field service engineers are trained in the installation and support of the lung adapter, and this does not impact your current SimMan warranty. Here's an image of the inside of the SimMan 3G before and after the installation of the lung adapter. Once the adapter is initially installed, it does not need to be removed in order to revert back to the standard SimMan respiratory configuration. The disc-shaped component acts as a toggle switch between using SimMan's lung bags and the ASL 5000. After installation of the SimMan lung adapter components, you connect the ASL 5000 circuit to an existing port located on the left side of your SimMan. A provided 60-inch ventilator circuit connects the ASL 5000 to the lung port on the side of the SimMan, making it possible for you to position the ASL 5000 as necessary to support the patient's position or the desire to hide the ASL 5000 during the scenario. As with a human patient, once intubated, SimMan's endotracheal tube connects to the ventilator circuit, with the ASL 5000 now providing his respiratory efforts and breaths. Chest rise and fall mirrors his respiratory efforts, both ASL 5000 generated and ventilator provided. Before we show you a short patient scenario, I'd like to take a few moments to also introduce you to our LEAP operating platform, updated with unique windows used to manage SimMan 3G's respiratory function and efforts. For those of you familiar with LEAP, you'll notice new windows on the left and bottom center of the LEAP display. The windows allow me to control the ASL 5000's breaths in real time, and to also observe how the selected patient is responding to current ventilator settings. The LEAP respiratory vital sign information also shows the changes, and the ventilator provides the appropriate feedback. In this view, you'll see the default IngMar layout features the quick choice menu on the left side of the LEAP instructor application. The quick choice menu is essentially a patient library including 5 pre-configured patient models with variable levels of severity controlled by a slider. The 5 patient library includes patients for COPD, ARDS, asthma, interstitial lung disease, and a normal healthy patient. For those of you currently using LEAP, it's important to note integration with the ASL 5000 does require LEAP 6.3 at a minimum. Our lung model control window allows you to make on-the-fly changes to both resistance and compliance. And the breathing effort control window allows you to control the patient's spontaneous breathing. During a scenario, we have 2 ways of displaying real-time respiratory waveform information. The example on the left shows flows, pressures, and volumes, as well as data that can be referenced by the instructor, such as PEEP, tidal volume, minute volume, and other parameters as well. Alternatively, on the right, we show a view based on the equation of motion, showing the different components acted out in real time. Now that we've briefly overviewed some of the LEAP ASL 5000 controls and information, we'll show user interaction with LEAP and SimMan's interaction with the ventilator. Our LEAP theme presents a patient managed by a ventilator that starts out in distress and then responds favorably to changes in the ventilator settings. To set the stage, here's the background leading up to our scenario. You're the respiratory therapist coming on shift. Our patient came into the emergency department for a COPD, exasperation, and hypercapnic respiratory failure. He was placed on BiPAP for 2 hours without any level of success. So the treatment team decides ventilator support is the best option, and the necessary steps were taken to sedate, intubate, and go ahead and place the patient on the ventilator. So you're coming on to shift and see the patient is visibly more awake, restless, and the ventilator is alarming.
To demonstrate the integration of the ASL 5000 and the SimMan 3G, we've created a theme that we're going to use within LEAP. I've already staged the theme to where it's ready to go, and as you can see on the screen, our theme actually presents us with a setup checklist. So as I select the ASL 5000 settings, you can see it tells me I need to go to the ASL quick change menu and select the COPD disease state. So I'm going to tab through my carousel for disease states, get COPD on the top, and then I'll click on apply as the directions say. So the next step is to take the severity slider and set that to severe. So here you can see my severity slider, and I'm just going to click on severe. Then we want to select on the run icon, so I'm going to step down, click on run. And at the same time, we want to change our breathing effort control window setting where the vital signs change within 5 breaths, as I'm doing here. Once I've done that, I can click on OK. and I get another message box that actually provides me with all the initial settings for the ventilator. So once those have been taken care of, we can actually call our treatment team into the room and begin the scenario. So as they enter the room, they can immediately see that the ventilator is alarming because peak airway pressures are over 40 centimeters of water. This would be a very dangerous level, likely to cause lung damage. We can also observe that the patient's total respiratory rate is 27. That's higher than our ventilator is set at, which is 20, so this does indicate that the ventilator is detecting our patient's spontaneous breathing efforts. If we look a little more closely at the flow waveforms, we can also see there's clear evidence of air trapping. The flows are not returning to the baseline or to zero. So based on the patient's vital sign, which he has an elevated heart rate and his SpO2 is actually at 88, the decision is made by the respiratory therapist that we do need to change the ventilator settings to make the patient more comfortable. So the respiratory therapist is actually going to switch over to pressure-controlled ventilation, which is normally more appropriate for a COPD patient. We're going to go back over to our LEAP screen because now that the respiratory therapist has made that decision, we're going to select the theme state called COPD moderate. When I click on activate, this will now cause the patient's vital signs to transition, and as you can see by the instructor's message, it tells me that I want to set the severity slider down to moderate, and then I'll click on OK. So while my patient's vital signs are transitioning and a respiratory therapist has now made the changes to the ventilator settings, we can see that the peak pressures are now down to about 22 centimeters of water, a much safer pressure. We'll still see a little bit of air trapping, but this is common for COPD patients. The vital signs in LEAP have also moderated. Our heart rate is now down to 91. Our SpO2 is up to 92. And the blood pressure has actually dropped down to 130/85, a much more comfortable patient. So at this point, the simulation facilitator has decided to terminate the scenario, takes the participants in to review the scenario, capture their comments, and to also update the debriefing file.
So to summarize, with the ASL 5000 lung solution, the SimMan now exhibits the range of resistance and compliance settings necessary to create a virtually unlimited number of respiratory disease states. Most importantly, the SimMan becomes capable of breathing spontaneously while being ventilated. So it's perfectly suited for high-fidelity ventilator management training.
Thank you, Joe and Brian. We're now going to begin answering the questions submitted during today's presentation. As a reminder, you can still submit questions through the Q&A pane in your attendee control panel. We'll get to as many as we can. Joe, our first question is for you. Who should I work with for a quote, and how much does this cost?
Please contact your Laerdal representative for pricing information, or provide your information to IngMar Medical, who will connect you with your Laerdal representative.
Our next question is for Brian. Brian, we have someone who already has an ASL 5000. Do they need a hardware upgrade for their ASL 5000 to be compatible with the lung adapter?
Okay, so if your ASL 5000 serial number is 1065 or higher, your unit is already compatible with the lung adapter and does not require a hardware upgrade. But if your serial number is below 1064 and has not been previously serviced, then please contact IngMar Medical and we will help you determine the steps necessary to make sure it's compatible.
Our next question is for Joe. Joe, do I need to upgrade to LEAP in order to use the ASL 5000 lung solution with my SimMan?
Thanks, Cassie. Yes, LEAP is required. To upgrade to LEAP, please contact your Laerdal representative or visit laerdal.com/LEAP implementation. That's spelled LLEAP, implementation as one word. If you're already using LEAP, version 6.3 or higher is required. You can check for new software updates anytime from the LEAP homepage or visit laerdal.com/downloads for the latest LEAP version. Biannual software releases are available for all Laerdal simulation software at www.laerdal.com/downloads.
So Brian, we have for you, do changes made in the ASL 5000 windows automatically trigger changes to the SimMan's vital signs?
Not completely, though as we demonstrated today, it's fairly easy to use a simple theme to integrate the vitals of the SimMan with the control of the ASL 5000. But the respiratory rate, as detected by the ASL, is automatically linked to the respiratory rate on the Laerdal patient monitor.
Our next question is for Joe. Joe, and I think we talked about this a bit, but maybe you can give us some more detail. Is installation required?
Yes. Although the lung adapter installation is fairly simple and straightforward, assuring proper setup and software configuration is critical. So in order to protect the warranty of your simulator, installation is required.
Brian, we have a question about connection. Specifically, can I connect this setup wirelessly?
The ASL actually has to be hardwired to the chosen network using an Ethernet cable. But the computer running the LEAP software can be connected wirelessly to that same network.
Joe, our next question is for you. What about using this with my other Laerdal simulators like SimMan ALS or SimBaby?
We're always interested in expanding our training capabilities, though we do not have a timeline to share today for future developments. We're in close communications with our partner IngMar and are working together to provide the best possible learning experiences.
I think we have a couple extra minutes, so maybe we could answer just a couple more questions before we run out of time today. I do see a question. I think this would be for Joe. Joe, will there be chest rise when the ASL 5000 is in the mode that bypasses the SimMan 3G lung bags?
Yes. Because at that point, we actually look at chest rise and fall the same way that we always have. So we're just looking at the given breast by the ASL 5000, then chest rise and fall will respond accordingly.
Brian, I see one for you. Are we able to make and save our own simulations in the new software? So the new, the 5 cases that are in the IngMar software?
Yeah, absolutely. So the newest feature we've added to the plugin allows customers to save their own patient models. So basically, they would be able to choose their own combination of resistance, compliance, and spontaneous effort, and then they can simply save these new models to create a patient library of their own. Cassie, if you don't mind, I see one here that's a good question from Donna. Donna asked, do you no longer need an external air compressor when using the ASL 5000? So that is correct, Donna. An old solution that we had for making this integration happen did require an external compressor, but now that we've formed a more seamless integration with the SimMan, we're actually controlling the compressor that's located in the leg of the SimMan to produce the chest rise.
Thank you for that, Brian. We are out of time for today. On behalf of our presenters, thank you for joining us today. We hope to meet many of you at IMSH in January, and have a great rest of your day.